Welcome back. In continuing our conversation about writing equations of lines, the last thing we're going to discuss is talking about parallel and perpendicular lines. So remember, parallel means that the lines run right alongside each other, but never touching. And so what that means is your slopes are the same. Okay, so here you have same slopes. Perpendicular, they cross at a 90-degree angle. And so what they have is we call them opposite reciprocal slopes. Okay? So the first piece of this note is just going to be figuring out what is the slope of my new line. Okay? So let's really quickly run through. So here I just give you a bunch of equations and I want you to identify what are the slopes of the parallel line, what are the slopes of the perpendicular line. Parallel is really easy. Okay, the slope of the parallel line is always exactly the same of the slope of the given line. Okay. The perpendicular slope, however, perpendicular slope means you have to flip the fraction, flip the sign. You need opposite reciprocal. So because the slope started as negative, now it's going to be positive, and I flip it to be a fraction. Okay? So let's do another one. So here, if I want a parallel slope to this, the parallel slope would be exactly the same. If I want a perpendicular slope, it means I flip the sign, so it was positive, so now it's negative, and I flip the fraction. So my perpendicular slope is going to be negative 5/3. Now this next one, hopefully you see what has to happen. I can't see the slope right now, correct? The only way I can see slope is if it's in slope-intercept form. Okay, so that means first and foremost, I actually have to solve this thing for y. I have to subtract the x over and divide by 3. Okay, then and only then can I see what my slope is. So now I see the slope of this line is negative 2/3. So if I want the slope of a parallel line, remember that's going to be equal. So the parallel lines are going to be exactly the same. For perpendicular, remember flip the sign, flip the fraction. So it was negative, so now my slope is going to be positive, and I just flip the fraction. So not too difficult, but you do have to know the differences between the two. Parallel, same slope. Perpendicular, opposite reciprocal. And then make sure you're actually looking at the equation that you can see the original slope. If you're not, solve it for y so you can see it. Now, what if I want to write a new equation? Okay, because that's really the goal here, is talking about writing equations. So the idea is if I give you a line and I say write a parallel or perpendicular equation through this new point, okay? The first thing is you can use the rules of parallel and perpendicular lines to determine what your new slope has to be, okay? And then the idea is if I give you a point, that's enough information to write a point slope equation. Okay? And then once you have that, now you can solve for y. So let's work our way through this. Okay? So write an equation in slope-intercept form of a line parallel to y equals 3x plus 2 that passes through that point. So if I want something parallel to this, that means my new slope is still going to be 3. My slope is going to be the same going through this point. So, like I've been kind of conditioning you to think of, the information that's provided to me, that information is going to allow me to write a point slope equation. Y minus the y value from the point equals the slope x minus the x value from the point. But now what it actually wants is slope-intercept form. Okay, so remember slope-intercept form means get y alone. So now that I have my equation, now I manipulate it to be in the form that I need. So I'm going to distribute that 3, and I'm going to add the 7. And there's my line. So that's kind of the process that we need to do for all of these. All right. So let's look again. Write an equation in slope-intercept form of the line perpendicular to negative 2x minus 1 that passes through the point 4, negative 1. All right, so I want something perpendicular to that. So remember, a perpendicular slope is going to flip signs. So the original is negative, so now I have something positive, and flip the fraction. So my new slope is going to be 1/2 through this new point. So remember, that's enough that I can write a point slope equation. All right, y minus the y value from the point equals my slope x minus the x value from the point. So now I'm going to change that. A double negative is always a positive. And now let's identify the fact that I really am looking for a slope-intercept form though. Right now I have point slope. So I'm going to go through and I'm going to transform this to be in the right format. And remember what that means is I have to get y by itself. So I'm going to distribute the 1/2. 1/2 times negative 4 is going to give me a negative 2. And then subtract off the 1. And there we have it. And one last example. Write an equation in slope-intercept form of the line parallel to 2x plus 3y equals 6 that passes through the point negative 6, 5. Now, what you're probably going to notice is we want a parallel line to this, but I can't see what the slope is. So remember, one of the key things to know is sometimes you have to solve it for y to find out what the slope is. So I'm going to subtract off the 2x and divide by 3. So now that is my slope, okay? And the slope of a parallel line is still going to be the same. So I have a slope, I have a point, so now I have enough to write a point slope equation. So y minus the y value from the point equals my slope x minus the x value from the point. And then, of course, a double negative, you're going to flip that to be positive. So here's the equation I've got with the information I was provided. Okay, so now I'm going to use that information because what I really want is a slope-intercept form equation. So to do that, remember that means we're getting y by itself. So I'm going to distribute that negative 2/3. Y minus 5 equals negative 2/3 x. Negative 2/3 times 6. Again, I'd recommend use your calculator for that, okay? Let the calculator help you. And check that you get a -4 for that, okay? Again, it's okay to use your calculator for little computations like that to make sure that you're doing them right. And finally, to get y by itself, let's add the 5. And there is your equation. So, a lot of good stuff in this video. And again, it follows kind of the same format that you've seen before, using the information that you're given and then transforming it for the information or the way that they want you to present the information. So thank you for joining me for this. And once you're done finishing up these notes, then you can move on to the practice work.